Hey, welcome to AISangam.com. Yes, today we are going to discuss about the important topic, which is classification using naive Bayes. As you could see, the front screen, it contains an image which has a magazine, newspaper, and a book. Another is a face and something right face is written on it. There's a another content where spam filtering is written. Okay. Now, starting with the part what is namespace. In the previous video, we have gone through spot vector machine. These some videos I am covering about the machine classifiers, and this is one of the probabilistic classifier which we are covering. Now, if I could go through this page again, I say it is a classifier which can do text classification. It can differentiate between a magazine, newspaper, and a book. It can tell you whether this particular data that you are obtaining, it is related to business, it is related to economics, it is related to finance and something. See, it is used to filter the spam. It is used to recognize the face in the real time. It is used to do the medical diagnosis, that is used to detect whether the person has a particular disease or not. It is a classifier, so it will predict in the form of labels, class, or discrete values. So in the outline part, we are discussing about introduction to the namespace. We are discussing about the pros and cons of namespace and the applications of namespace with respect to machine learning. And finally, how to build a basic model using namespace. You could also subscribe our channel if you like. What is namespace? It is a classification technique based on Bayes theorem. Classification refers to predict a discrete class label. Classification algorithm can predict a continuous value but in the form of probability for a class label. Various other machine learning classifier models include a linear classifier such as logistic regression, spot vector machine, decision trees, random forest, neural network, and Naive Bayes. Naive is generative learning model, which is based on the probability, which we will discuss in the next slides. Now, there should be have some discussion on what is a generative model and why it is a different from discriminative model. Generative model cares about how the data is generated, while the later does not care about while performing the classification. In simple words, I say that the data comes to it basically cares for the data as well as the target. Maximum entropy, Markov model, naive space, probabilistic, context free grammar are some of the examples of generative model, whereas the logistic regression, spot vector machine, neural network, and hidden Markov model are discriminative model. Former model the actual distribution of the class, while later models the decision boundaries. Basically, in generative model, we have the data and it actually applies some sort of the probability on it and then classifies the new output based on the maximum likelihood. Whereas the former tries to learn probability of y comma x, whereas the later learns probability of y slash x. So these are some of the difference which we have explained between generative and the descriptive model. Now, as we could see in the outline, the namespace is basically based on Bayes theorem. So it becomes very important for us to understand what is Bayes theorem. I think all of the people have done this in the probability, in the engineering mathematics, in the secondary education, and even in the primary education. Probability of A, that hyphen slash B is equal to probability of B slash A multiplied by the probability of A divided by the probability of B. It means probability of A slash B means it is the likelihood of event A occurring given B is already occurred B is true. Okay, if I say probability of B slash A, it means the likelihood of event B occurring while the event A has already occurred. So you must understand the term to the left is always called as the posterior probability. The term to the right, this first term to the right, is always called as a likelihood probability. P of A is the prior probability of class and P of B is the prior probability of predictor. Predictor means the columns, the data set, whole set of columns or the data set, whereas C is the classification targets, whether these are discrete or class levels or whatever. So if you understand this theorem, it becomes very easy for you to understand the Nave's Bay. Now, how it works? It calculates the posterior probability using the Bayes theorem for each class, because when we provide the real-time data, it takes into account of the real-time data and calculates the posterior probability of each class for that particular data, and the class with the highest posterior probability is the outcome. This is what we need to understand. It is a generative model. It models the whole data keeping into consideration of the target. This is what the difference between discriminative and the generative arises. Also, whenever we see a coin, it has two sides. In the same way, it also has the two sides. It has some pros and cons. If I could see about the pros of it, it can be used for the multi-class classification. It works with the concept of independence of every predictor column, and in that respect performs better as compared to other model. It means every of the predictor column or the data column, it take into account, it is independent of each other. But if I am coming to the cons, it suffers from the zero frequency problem, which states that if the category of the testing dataset is not present during the training phase, it will assign a probability of zero. So it will assign a probability of zero. Sorry, I have not written here zero. Just I am mentioning here to write the zero here. Just you could write zero, or I may also write here the zero. Just give me a minute. So it will assign a probability of 0 to such. Okay. Now, next slide. And also one thing very important for us to learn, that is, all the columns to be independent to each other is practically impossible in the real life. That is also falling under cons of it. Now I am getting you some of the examples. It is used for the text classification, spam filtering, sentimental analysis, medical diagnosis, and face recognition, which you could see better in the first slide. It is detecting the magazine, newspaper, book, face, spam, something like that. It is also detecting the faces, sentimental analysis, and so on. So these are some of the applications which could be done by the other classifier models also, but this video pertains and sticks to the namespace, so we are focusing on the namespace. This is the last slide. How to build a basic model using NaveBay, or the heading could be how to build a basic model using any machine learning algorithm classifier. First step should be the data gathering. It could be from any particular open repository, or may the people have collected the historical data. Open repository like Berkeley segmentation, it's the ImageNet, it's the UCR repository, and there are a lot of repositories which is available from where the data could be fetched. Then the pre-processing, then the feature extraction selection method, which helps in reducing the dimensions and the dimensionality, splitting the data into the training and the validation set, then training the data using the Nave's probability model. For it, I have written mods. It is basically models. You may correct it sometimes. Anybody could have the mistake of that. It's basically models. Sorry for that. Now, again, the last is checking it on the validation data before the real-time prediction, and Now, last is why we are checking it for the validation data, because before the real-time prediction we should see the performance evaluation. What is the confusion matrix, what is the score, what is the precision, what is the accuracy, what is the FMIA and recall factors, so that before deploying for the real-time application, one must understand at which level the algorithm has really been trained and how we have successfully filtered the right data. Because if you are giving the clean data